Thank you, everybody, for joining today. I'd love to introduce our speaker for today, is Ivan Portilla, who's going to be presenting on the topic of models deployed at the edge. Thank you so much, Ivan, for joining us, and over to you.
Thank you, Victor. Can you hear me okay?
Yes, I can.
Okay, so let me share my screen. I'm going to be sharing my whole screen so I can switch back between the presentation and the demo. So you can see that. So welcome, everyone. We're going to be talking about innovation at the edge, edge computing, AI at the edge. My name is Ivan Portilla. I'm a data scientist and solution architect with the IBM Edge Computing team. And the agenda that we have for today is very simple. We're going to introduce the topic of edge computing. Then we will talk about our offering called Edge Application Manager. And Victor told me that we have some additional time. So if we can do it, we can run 2 demos. In the demo, I'm going to be talking about 2 components of Edge Application Manager, which is the model management system. And I'm going to mention another product, an IBM product called IBM Visual Insights. Some of you have done us on visual recognition, you probably recognize this product, or it used to be called also Power AI Vision. And then we'll open it up for questions. So what is edge computing? So companies are seeing a tremendous opportunity with edge computing. They can see how they can improve operational readiness, responsiveness, and reducing cost. Right now, we estimate about 15 to 20 billion of smart IoT devices connected, and we expect that number to increase to 50 billion by 2025. Also, with the rollout of 5G networks, will increase the demand and opportunities on edge computing. Nowadays, in this COVID-19 world, edge computing will have additional significance and potential, which is more important than ever. Some of the use cases that we are seeing right now, drones and even sensors for disinfection or diagnosis. Some points of entry, airports, they have these thermal cameras that can detect if you're sick or your site of work. And even to do crowd management, social distancing. Some of the drones have been used for deliveries. So what is edge computing? Edge computing is a distributed computing model that brings computation and data storage to closer to the point where the point of action of the occurrence of events. This will allow for more immediate application of analytics and AI capabilities. I strongly recommend to take a look at that IBM Business Insights report that is on that page. So this is what edge computing will look like on the enterprise. From left to right, you will these smart IoT devices. It can be anything from a $5 Raspberry Pi Zero to a couple of thousand smart camera powered by an NVIDIA Jetson TX2 board. Then those devices can be centrally or connected to what we call clusters or larger computers to run additional computation on that data being captured. And they are connected to a hybrid cloud environment through these gateways, through these edge networks. On the hybrid cloud on the right, we can deploy either on public clouds like IBM, Amazon, Google, or in private clouds in customer data centers. The product that we're going to be talking today is called IBM Edge Application Manager. Here's the definition and some business values. I have a couple of links on the page, and Victor is going to share these pages with you. This is the page that you can share with your clients. Explain the product. That is a life cycle offering to create, secure, monitor, maintain business logic applications, and run the analytics of AI across your edge computing. And we will see this product in the demonstration. Now let's talk about the user scenario. And we're going to be working with Elsa. She's the CEO, CIO of a global security company. And she shares some pain points with us. She mentioned that managing these hundreds of remote devices is overwhelming. Every time she needs to update the software on these sensors and these cameras, she doesn't have enough resources to do it in a safe manner. Her frustrations include that these software updates on these remote devices is time consuming and requires some additional capabilities. She's also under frequent security attacks, DDoS, and she needs to keep up with legislative regulations like GDPR for data privacy. When they make changes to the AI models, they usually require full system updates. And she deals with hardware and software vendors, and integrating those is difficult and costly. So basically, her goals are three. She wants to have a continuous operations. So even when her surveillance applications are disconnected, she want to continuously run these applications. She wants to have faster insights. So by moving the AI capabilities to the point where the data is created, she gets faster responses. And finally, she wants to have better data controlling of cost. So she wants to minimize the data transfer from these devices to central hub locations and reduce the security risks when she does that. So that's the use case. And for the demonstration, we created a simple demo where we will detect people wearing a hard hat or a helmet on a chemical industrial workplace. During the demonstration, we did this a few months ago. Because of the pandemic, we had to do it remote. So we set up a little lab here, one of our colleagues' garage. So we set up a mannequin there, and we have a camera, we have a nice computer with a GPU, and we run the demo this way. So this is the workflow that we're gonna follow. We have three roles. We have an IBM Edge Application Manager Administrator. This person, in my case, my picture there, is gonna be interacting with the hub on the user interface in a web console. Then we have a data scientist that is going to create that model to detect if the person is wearing or not a hard hat or helmet. And then we have a software developer. The software developer is going to take that model, create a microservice service using Docker containers, and is going to deploy that model into the hub. And is going to publish it twice when he gets updates from the data scientist. So I'm gonna walk you through all these steps, 1 through 10. And I'm gonna switch back between the PowerPoint presentation, the web browser, and virtual machines, VMs. So any questions before I start? Okay, so let's get started. So the very first step is to get to the device and register. So I get out of my presentation, I go into my device, which is this device here. I have installed a very lightweight agent on the device. Again, this can be a Raspberry Pi camera equipped with a microcontroller board. And I'm going to run a very simple command called registration. So I do an HCN, Horizon Register. And when I run that command, it's going to connect to my hub. And it's going to say, hey, I'm here, I'm registering with you, make me part of your collective. So if I go back to my browser and go into Edge Application Manager, which is this. This is the interface. I have 4 tabs on the product. I have nodes, which is all these devices that I'm going to manage. I have services. This is the services that I'm going to create. In this case, I'm going to use the visual recognition service. And I have patterns and policies. And I will explain what those are a little bit in the demo. But here on the nodes, I just want to see if my node has been registered. And it's right there. That VM26 is my node. And because of that command, I was able to register with the hub, and it's telling me it's a VM on the cloud. It's an AMD 64 architecture, and it has these default properties. So it tells me the architecture, the memory, and the CPU. So I'm going to be working with this node. And currently has no errors, and it has no services, microservices running. It's a brand new service. So if I switch back to my presentation, did the registration, I went into the management console, and I look at the node, and I look at the node properties. And I verify that the node is correct. So on this part, I'm gonna give it to Travis to show us how he's going to create that vision recognition model using IBM Visual Insights to detect if a person is or is not wearing a hard hat or a helmet. So Travis?
So, as said, my name is Travis, and I'll be the data scientist programming our computer vision model using IBM's Visual Insights. First, we log into the product and create a data set, which is compiled of various items that are folks wearing hard hats or the object that we're trying to detect. We appropriately label those objects simply by pointing and clicking and tagging all of those. You can create the labels on the right. Once we deploy that model, we then do a quick test of what that looks like. We see our accuracy is here, and we see our results down below, indicating that a helmet is detected.
Perfect, thank you, Travis. So we're going back to the presentation, and now Troy, software developer, is going to package that model that he receives from Travis, and he's going to build a microservice, and he's going to publish it to the hub, to the IBM Management Hub, so it is available to all the devices. So basically, I have this on the GitHub example. I have a makefile that I can build the Docker service. I can run it to make sure it looks good, and then I can publish that into the hub. So I will skip that part because I have all the instructions on the GitHub. And then I'm going to show you how to create a deployment policy. Remember, I have a node registered with the device, with the hub, and I'm going to use a policy, a deployment policy, to say all these type of nodes of devices can run this service that Troy just published. So with that, I go back into the console, go back here, and I go into policies. I'm going to add a business deployment policy. I'm going to give it a name, image, demo, business policy. And I'm going to select a service. And the service I'm going to select has image on the name. It's the one I created, that Troy created. And it has different versions. So I'm going to pick version 1. I click next. And this service has some restrictions, some properties. So I'm going to tell it that this service only runs on cameras that are located in the backyard. Click next, skip that one. Location is equal to backyard, and publish that policy. So now that policy will tell all the devices that are registered with the hub where to run that service. So I go back to my node and modify its properties. I'm going to add the same property that I have there, location is equal to backyard. And I'm going to add another property called sensor. So this is a sensor of type camera because it can have sensors for audio or other things. Okay, so now this device is registered with the hub with those properties, and I create a business deployment policy. So let's go back to my presentation. So I did that, created the deployment policy, and it has some properties that I added to the node. And I'm gonna ask Travis to show us his model to do some simple testing. And we call that version 1 of the model. So Travis?
So now that Troy has deployed the model, we'll go ahead and select our version 1 model from the list and go ahead and click on play. So what you see here is a live video camera with my webcam and the safety model version 1 deployed. Here to the other side of the screen, you'll see the image analysis results. If I go ahead and put the hard hat on and analyze the image, I should see whether it's passed or failed here to the right in the results. So here you see that it has passed with a confidence rating of 99.87, saying that it's a helmet. That's great, you would think, right? So for version 1, we'll also analyze without a helmet. And now I'll go ahead and analyze without wearing the helmet. The image analysis results, again, will appear down below, and you'll see that they are slightly the same as what you saw earlier, and I'll explain why in just a second. So the image results say that it still passed with a confidence rating of 97%, that I am wearing a helmet, and I'm clearly not. Therefore, we're going to go ahead and deploy an update to the Edge device for the camera and this model.
Thank you, Travis. So we'll continue with the presentation. And now, remember, with that model version 1, the accuracy was not very good. He was not detecting when he was not wearing the helmet. So he revised the model and is going to create a version 2, hopefully with better accuracy. So Travis, can you show us that?
Now, as mentioned, we're going to go ahead and update the model. So I'll log back into our IBM Visual Insights product, select the new data set or add to the existing data set to create the safety model version 2. We'll relabel and add additional components and label more accurately this time to create a more accurate data set. We'll deploy that model as version 2 and go ahead and test it in addition. You'll notice testing it with the same image actually allows us to identify 2 helmets rather than 1.
Thank you, Travis. So now that we have an update to the model, Troy is going to push that update into the hub, and the hub is going to send it down to the node. So typically, this will require that you build another container, stop and start the container with a new model. With this capability of Edge Application Manager, you don't have to do that. You only publish whatever changed, be the model, the labels, the frozen graph, and so on. So I will show you that in the second demo, but it's a simple command to publish that object. And this is the details. I'll show you that in a minute. And this is the way the model moves. It goes from the developer's workstation into the hub. And then because the node is subscribed to the hub, it pulls that model update into an agent running on the node. And then the Vision application can consume that model update. And finally, let's do our final test. with the version 2 model now that it has been published to the hub. So Travis, show us that.
Okay, now that Troy has deployed version 2 of the model, we'll go ahead and select that version and go ahead and analyze that image next. So you'll see the image analysis over here to the right after I analyze it. Let's try it first without a helmet. So here, the results indicate that there is no helmet. It double checks and it fails. And it's 68% sure that it's bad. And there's not even an applicable helmet in the labeling. So this model is validating that there's no helmet. This is a very good thing. This is indicating our model is correct. Let's go ahead and put the helmet on just to make sure that the image or that the modeling is correct. Again, version 2 of the model has been deployed by Troy. And now I'm going to go ahead and analyze this image. And you can see that this is passed with 99.81% confidence that there is indeed a helmet.
Thank you, Travis. So I go back here and talk a little bit more about this offering. So what we saw was called Visual Insights, working with Edge Application Manager. And now that has been made into a product that is called Maximal Worker Insights. And this is being used in several use cases, particularly with COVID-19 clients. So you have all these devices being managed by a central location, the hub, and then be able to update model updates through the Edge Application Manager. Plus, we also have use cases for phones, for smartphones. Since the smartphone doesn't allow us to manage from a central location, the Apple Store or the Google Play Store, they don't use the Edge Application Manager, just use the Visual Insights. Yeah. So with that, I'm gonna start the second demo, but I want to stop here and ask if anybody had any questions about this demo that we just saw with Visual Insights in IAM.
I have a question more regarding to the Visual Insights capability.
Okay.
Does the solution also, is it able to identify like safe distancing, the 1 meter, 2 meter?
Yes, it does. Very good question. Yes, it does. Very good question. And I have a few slides in a minute to show you more details about that. So great question.
Okay.
Thank you. Okay, so put a pin for the question for a second. I'm gonna show you my second demo. In this demo, we already talked about the virtual machine 26 that is now registered with the hub. And there's a policy on the hub that make that compatible, so I can deploy that another visual recognition model that I created. And I'm gonna be using my Mac machine to update that model. So I'm gonna switch here. And here I am logging into that virtual machine on the cloud. Can you see that? So this is the code in my GitHub repository. So like I say, you create a service with a Docker. So this is what the Docker file looks like. And it's very simple. It uses Alpine Linux distribution, which is very small. And you just copy the contents of the HTML folder into a web host and then expose port 80. In the HTML folder, I have an index page and an index.js, and I'm using TensorFlow Lite, TensorFlow.js. So if I look at that index.js, all I'm doing is loading, initially I'm running a MobileNet model from the model zoo, and I'm running the inference. So I would like for you to come along my demo here. So if you go to this address, 52.116.226.90.80, I'm gonna put it in the WebEx chat so you can have it. Go to that page and then open your developer tools and look at the console. So if you look at the console, you notice that with that image, load MobileNet model architecture, and it detected 3 things. So obviously those are not the things on the picture. So I try a different image. And for that image, it detected, it's a little bit better, right? But the first image was not quite right. And again, this is running MobileNet model. So now I go back into my machine. My machine is here, my Mac, and I do a make publish MMS object, which is just a make file to call an HCM command. It calls this object publish and passes a JSON object and passes this, this is the model update. So if I do make list MMS objects, I can see that that update, that index.js, this is a TensorFlow.js, got delivered to my node 26. And if I go back into my node and I do a make list files and I enter my password, I notice that my update was deployed. Okay. So if I go back, if you're going with me into the browser, do a refresh, notice that my model now is Coco SSD, single shot detection. So it loads that model that I just published from my Mac machine into the hub, into the device, and look at the detection. It's a much better detection. Now it detects a dog and a cow with a higher percent accuracy, 84 and 60%. And if I test it on my other image, it's still even better, cat 90%. So any questions on model 2, on the demo 2? I register the node, I publish the update to the hub, and it downloaded. If I go back here, I detected the animals in my backyard. That's the GitHub repository for the code. And what I did was I put the model into the hub in the node, because it's subscribed to the hub, pull that update down into the agent, and the Vision application consumes that update, and it gives me better results without touching the device at all. So the question about can it detect faces or crowds, social distancing? Yes. So you can request an instance of this environment using the Client Experience Center. So they will deploy for you Visual Insights, and then you can train it. You can upload pictures, and you can measure, or you can highlight the people in the picture. So that's one option, using Visual Insights on the cloud, on the Client Experience Centers. Or you can use something called Cloud Annotations AI. In this, you can annotate your own pictures, and you can create a model and download it. That's another place you can use. But the recommended one is this one, the Model Exchange. So on developeribm.com, we have this exchange place, and you can download. There's a couple of models that already do that, social distance, social people proximity. So you can go to that URL and download the model. It's already trained. It's all ready for you to consume. Okay? So 3 options: Visual Insights on the cloud, Cloud Annotations and AI on the developer, and then this Model Exchange website when you can already download the model trained. The first 2 use Watson machine learning API under the covers. Yeah, some resources. And that's all I have for you today. So Victor, open it up for questions.
Yeah, thank you so much, Ivan. Great presentation. Very exciting and very relevant to what we're doing. So let's open it up if there are any questions. There are no questions in the chat so far, but everybody's pretty quiet. No questions. Okay, well, if there is no questions, Ivan, thank you so much for coming, joining us during today's couple session and for presenting this. We'll post the replay shortly. It's also going to be available on Your Learning. If somebody wants to listen to it later, if you guys want to share it to other members of your team. Thank you again, once again, for joining us today, and have a great day, everybody.
Thank you, everyone. Bye.
Thank you. Bye-bye.